Steve, for that introduction. So let's get right into it. And hang on. There we go. So this is going to be the outline of our talk. I won't get into the various details. You can go ahead and read that. We'll move on ahead. And let's talk about the background of facets and phi. For those of you who are or are not familiar, phi is kind of a part of facets. So facets is the Forecasting a Continuum of Environmental Threats initiative that was started at NSSL and is now starting to grow throughout NOAA. This is a next generation severe weather watch and warning framework designed to communicate hazardous weather information to serve the public. It's designed to go across all scales, time and space, and all phenomenon of hazardous weather. But what you're going to see here is kind of the first part of that, and that is the warning time and space scale for tornadoes and severe thunderstorms. So what the WFOs are doing right now for warnings. So phi, probabilistic hazard information, these are rapidly updating probabilistic hazard grids, and in our system right now, the resolution is 1 kilometer by 1 minute. So these grids are updating every minute. And then the phi grids can be used to provide custom user-specific products that can be tailored for their needs. For example, if there's an entity out there that could stand to benefit from longer lead times of a hazard that's heading toward them that may be outside the time duration of today's warnings, they'll be able to get something like that, but it'll be at a lower confidence. But this is okay because these might be more vulnerable populations with a lower tolerance for risk, meaning they may need more time to respond to the risk, or they're more exposed to the risk. They're outside or something like that. So what would phi look like in our world? Now, what we're intending to do here with phi is not necessarily replace the warnings with numbers and grids, but essentially what we're doing is we're adding another dimension and another layer underneath the legacy warnings, which would be these probabilistic grids, and from which we can draw a number of different kinds of alerts, warnings, and things like that. So this is an example from a real-world event up in Colorado. If you recall, a tornado that hit Windsor, Colorado, and actually the storm moved to the north-northwest, so that's why it's pointed in a direction you're not used to seeing. And essentially what we're doing is we're evolving from a product-centric to an information-centric paradigm where the forecasters are providing information from which products can be derived. So we're going to have the forecasters convey the threat probability in grids using the new threat management tool, which is what Hazard Services phi is designed to do. And legacy products can result from predetermined thresholds applied to binary decision making. So it could be such that the legacy products are derived from a probabilistic threshold, as is seen in this case here, or they may be derived from the grid based on a lead time or duration threshold. So it might be, they might issue warnings based on whether or not you're 30 minutes away or something like that. But with this, it opens the door for new products and services such as low probability, longer lead time warnings, as I mentioned earlier. So it might look like something like this. So we've had a history of phi that started out in Norman, and the first ideas for this were born around 2006 and 2007, and then those ideas were turned into the first semblance of prototype reality within the Warning Decision Support System 2, or WIDS 2, which was tested in the hazardous weather testbed in 2007-2008, and there's a picture of what it looked like on the WIDS 2 system back then. The project was a success, but one of the biggest takeaways we got from the forecasters, and I think we had about 18 forecasters in total come in for this test, is that we need this stuff in AWIPS. That's going to help for them to transition to using these new technologies in a system that they're using right now in operations. So the project kind of remained in stasis for a few years, but then new life was breathed into it about 4 years ago when a second modern NSSL PHI prototype was developed using a web browser-based design, and this has been tested in the test bed 2014 up through this year, so 2017 as well. What we did with the design on this is to immediately look at what hazard services looks like right now in terms of where things, specific areas of the screen are laid out, such as the spatial display, the timeline console, and the hazard information dialog. So the web-based prototype browser-based design was given the same kind of layout in its design. So, and during the test at the test bed with the prototype, it was integrated with a user component where we had emergency managers and TV broadcasters coming in and looking at PHI output as presented to them within the ED, the Enhanced Data Display, to display custom products derived from PHI. But one of the purposes of the test of the prototype is to vet particular functionality on the system, which we then determine is now ready to be integrated into the hazard services platform. So as Steve mentioned, we're operating under a USWRP 3-year grant. We're in the 3rd year of it now, and this grant is funding us to develop the initial capability of PHI within the AWIPS 2 experimental hazard services. We first tested it in 2016, and we tested it again in 2017. So we're going to slide 6 now, Tracy. This is where you come in.
Okay.
And we're going to be going back and forth, and Tracy and I have a script. So.
Okay, so what you're looking at here is a picture of the 11 sub-projects that are being funded through the USWRP grant. And they span the realm of, or the spectrum of different facets, from the PHI guidance information, you'll see those sub-projects on the left, to forecaster tools, testing and verification. Those are the middle box of sub-projects. And then we have projects based or focused on the end users. So from guidance to the tools to end users is the full spectrum of the facets. And hazard services is sort of in the middle of that as the vehicle to operations. During the 3-year USWRP project, we are going to achieve a readiness level of 6, which is basically a prototype system tested in a relevant environment. So the hazardous weather test bed is our relevant environment. We have forecasters come in, and we'll talk a little bit more about that, with a very rigorous and rich set of exercises that they go through to test this functionality and the whole workflow process. So the operational readiness will then continue after, it would have to be after the USWRP grant to achieve higher levels of readiness. Okay, next slide. So we've been working with a cross-organizational team, and we've found this to be extremely successful, with each team bringing different expertise to the table. We're working with MDL, and Greg is the experimental design coordinator. He acts as the product owner for writing all the functional tests and prioritizing tasks. And he provides a conduit between also the PHI prototype that he just mentioned and then the PHI and hazard services. So he is really the visionary for this as well. GSD, our role is to do the software design and development, being the owners of hazard services in AWIPS for this particular project. So we are integrating it into AWIPS, and we're integrating the hazard services concepts. We're also, of course, using VLab, so all of this work is being done on the VLab platform. Forecasters are another important component of the team, and they come in to try out the new paradigm and give input and feedback for improving the software. Then NSSL, they are the owners of the facets concept and collaborations. They provide IT support, and of course the hazardous weather test bed is hosted there. So they are, and they also have the overall management of the entire USWRP grant and funding, and help with the future funding. WDTD, the the training organization, also housed at NSSL, is again another component of the team. They develop the training and the exercises that are used in the hazardous weather test bed. And finally, we have a collaboration with the University of Akron social scientists who bring in the human factors and work with the forecasters to determine the best human factors for the forecaster tools. So as I said, this team across organizations is a win-win for everyone. Next slide. So in year 2, what we did was throughout the entire period have weekly design and planning meetings with the entire team, of course teleconferencing. Development and testing was done at GSD, and we used the VLab. Starting in May, we set up a single machine test environment at GSD, and in September we had a dual machine test environment. So, and then what we did is make a major shift in team dynamics and progress starting in October by coding and testing against detailed functional tests that were provided by Greg and company. And then we used WebEx so that developers here in Boulder could watch as Greg, say, as the product owner, did the testing in Norman. And so we were able to then learn so much about how to get the software working according to the requirements and what was needed. And that was successful, so that in March and April we began the HWT experiments and continued improvements even in the off weeks of that experiment. Next slide. So developments in year 2 included, we were using the 2015 version of the NSSL PHI prototype as the benchmark. So new functionality, we added what we're calling the convective recommender, which basically takes prob severe data and creates initial objects or automated objects of probabilistic hazard information. Then we worked on the workflow for editing those objects so that a forecaster can take over some of those objects, and we had different levels of automation where the forecaster could create manual objects or assume partial or full control of the automated objects coming from prob severe. We also had new drawing tools for ellipses and rotation, resizing. We're able to end objects and finally do the PHI output grids and discussions. So the next slide shows you a screenshot of the hazard services version of probabilistic hazard information. You see the hazard information dialog on the left that allows the forecaster to edit the probabilistic information, and then the spatial display shows the probabilistic plumes coming, in as part of the object. And we have, of course, the console that lists the objects down below. The next slide shows an animation of then the PHI grids that are output from this process. So this was during one of the experiments, and you can see the number of PHI objects that the forecasters, in this case there were 2 of them collaborating, that the 2 of them collaborating were following and editing and producing these PHI grid output. Okay, I think we're back to you, Greg.
Yes, so let's talk about the experiment and our objectives, and there were a number of them. So one of our primary objectives was to evaluate the components of the software and the performance so that it can be improved before operational implementation. So that was our technological component here. We also had the human factors, as Tracy mentioned, the folks from the University of Akron who were measuring forecaster workload using the software, which included ease of use and the graphical design. They developed a number of different surveys online surveys that the forecasters took after each one of the cases that they went through, and we also did a lot of post-case round room discussions with the forecasters as well, so we collected a lot of data from them. We're also looking at the methodology. This is kind of more or less the training component, and this is how we assess how the forecasters will adopt and evolve their current warning methodology into the hazard services PHI environment, including evaluating the human-machine mix with the automated prob severe guidance. And then finally, conceptology. We really can't do a project like this without talking with the forecasters about their thoughts on the entire paradigm change from the deterministic warning products to probabilistic hazard information. This is a real big change in the way that operations are done, but we still feel that they are somewhat definitely interconnected with the legacy as well. So our experiment occurred in 2017 for 3 weeks plus a shakedown week that occurred about a month before we started. All the training materials that we provide the forecasters are hosted in the virtual lab collaboration services. And you can see kind of our daily activities there. We did just a typical 8 to 5 shift, days 1 through 4, which this year was Monday through Thursday. And on each of those days, on day 1 was primarily our orientation day, getting them trained on the system, getting an idea of how it works, and putting them through the first scenario, which is a simple, single isolated severe hailstorm that they tracked using the software. Days 2, 3, and 4, we progressively gave them more and more challenging events. These were all archived cases from events in the past. We did not run on real-time data. There are advantages and disadvantages for using real-time data, but for this particular project, we decided to stick with archived data alone. And then on the last day, it's a half day because they use the afternoon to travel back home, but it's kind of our end-of-week interview surveys and things like that. And you can see we had a couple of social events in there too, so we get to know our forecasters as well. So group dinner on Monday and a group lunch on the last day. So what kind of scenarios did we look at? We tried to put the software and the concept through a number of different tests to see how well it holds up. So as I mentioned on our first day, we did an isolated marginally severe storm, and this provided the forecasters with the basic concept of PHI and using the software for PHI. And then our next scenario was a developing supercell that turned to the right during the scenario. So the concept of PHI are these object following or storm following objects. So as the storm starts to turn to the right, the downstream plume also turns with it without us having to put a new polygon to capture the new motion. Then we looked at merging and splitting supercells. So this is dealing with many events in very close proximity. Then we went all out with a quasi-linear convective system that contained a whole bunch of tornado reports up in Iowa. So this was kind of looking at the concept of multiple scale PHI, and you can kind of see if you squint your eyes in the picture, we have our tornado plumes in here, but we also have this overall larger plume that's been issued for the whole squall line, which is a very lower probability of tornado within those areas and for a longer lead time. Sorry about that. Low shear summer southeast microbursts is another case. That's this over here. Then we did upscale growth to a squall line. So we're talking about individual storms that were merging into larger objects. So that can kind of get very challenging. And then finally, we did a case where we created 2 what I call fake county warning areas, but we had a couple of storms interacting with those borders, and we sequestered our 2 forecasters in 2 different rooms, door closed between them, and they were operating as independent WFOs and learning how to collaborate by handing off objects from one WFO to the other. So we had one object crossing immediately from one WFO to another, but another one that was straddling the border, which made it kind of challenging for them. As I said, human factors did some data collection. We did a pre-operation survey and one of the things that we asked the forecasters what their internal probability thresholds were for issuing warnings, so we can kind of get an idea if they're like issuing on 50-50 or a 20%, something in their head, if their thresholds vary by population density. We're also getting some feedback information pre-experiment on their use of Probsevere and the warning team composition, and even some of their ideas for warning improvement before they see anything with facets and PHI. We are collecting live video of the forecasters, both with cameras and through Record My Desktop, as well as our group discussions. We're recording those as well. Those discussions during the event and also post-event. And also they filled out several surveys, a NASA Task Load Index mental workload survey that asked of these different things on there, and a confidence survey. And then, as I said, on Friday we had our post-event wrap-up where we talked about a lot of stuff in a long interview fashion. Finally, the forecasters, of course, contributed a lot to all of this. They provided suggestions to improve the software, and this was independent of the PHI prototype experiment, which went on a little later in the spring. They also had forecasters providing suggestions to improve the software. So all these improvements are being now triaged to determine if they can be incorporated into hazard services PHI directly, or if they should be incorporated into both the prototype and hazard services PHI, or require proof of concept testing in the prototype first. Now, we did this triage, but since we did the triage, the collective expertise of one person basically who developed the PHI prototype has moved on in his career. So right now NSSL does not have a PHI prototype developer in-house. So we are in the process of determining what is going to be the fate of all this, and it looks like there's a very good likelihood that the PHI prototype may be nearing the end of its usefulness. So we'll get to that in a second, and what we're going to deal with that, how we're going to deal with that. So anyway, also the forecasters were helping us to formulate operational best practices, and that's why the WDTD folks over there to gather information. So slide 17 for Tracy.
Okay, so just looking back at our year 2 findings, we definitely made improvements in our team process from year 1 to year 2. The systematic software releases and then virtual testing between Boulder and Norman really allowed us to progress and make a more stable system platform for the year 2 test. So forecasters were able to complete all the required scenarios without major software interruptions. We do find in both years that this cross-WFO collaboration and object handoff is going to require significant analysis. Do you want to talk about that for a second, Greg?
Yeah, so as we know now, when we look at warnings as they cross borders between CWAs, there's some inconsistency. It's not seamless. We have the same issue with our forecast grids as well. But with warnings, we can see things like warnings being dropped as they cross a border, even though the storm may look the same, or a severe thunderstorm warning becomes a tornado warning, or even we see warnings issued downstream of a storm inside one CWA while the storm is still back to upstream of them. So what we're hoping to do with Hazard Services PHI is develop tools that will help with that collaboration and object handoff. This is something that we're designing right now into the year 3 experimentation, and I think we talk about that on a future slide. But also we wrote a proposal for OWOC for an HWT proposal. Unfortunately, it was not accepted. So we're kind of hoping when more requests come along that we'll pursue other means of funding for that. But we think this is a very, very important aspect of PHI and facets that is going to definitely have to be touched upon before this goes operational. Back to you, Tracy.
Okay, and so even though we made a lot of progress this year in terms of functionality and a stable platform, we still found that there were software performance issues that are impacting the forecaster experience. So if we go on to the next slide, we'll definitely be trying to address those performance issues and continue addressing stability. So we're working on those now. Here's just a list of some of the things that we're going to do to try to address those performance issues. And then, of course, continue to refine functionality, ownership of hazard objects and locking, as we just discussed, to facilitate collaboration will be a big focus of this year, in addition to the performance improvements that we'll try to make. Okay. Next, for you, Greg.
Yeah, so in year 3, we're also, once we felt we've completed developing all the 2015 prototype functionality, we're going to start IDing some of the new functionality that's been incorporated in the prototype since 2015. And there's a lot there. So, and right now the candidates at the top of the list include adding PHI objects for cloud-to-ground lightning prediction. This is something that's been tested already a couple of years within the prototype, and it's showing a lot of promise. So we think this is something that not only is something that we could most likely easily integrate into the hazard services version of PHI, but it might actually end up being one of the first kinds of PHI that we start developing reproducing operationally, because we don't have anything for lightning right now. So the risk for having lightning grids is a little lower right now than adding grids to tornado and severe. Another thing that we're looking at, obviously we've got PHI grids now. What do we do with them? And we want to go ahead and try to develop a legacy warning product that goes with them, so it'll look like the current ASCII warning right now with a VTech code and that kind of stuff. This image you see here looping on the right, this is what we call threats in motion. This is kind of one of the aspects of PHI, and that is rapidly updating probabilistic hazard grids. But if we can derive warning polygons from those, we could potentially derive polygons that update every minute and follow the storm. So that's one thing that we want to include in this as kind of a step from where we are now to a fully integrated PHI, and that is having a system design that has no probabilities but just the moving threats in motion, as you see there. And then finally, we were just told that a storm longevity component, which was tested in the prototype, appears to be ready to be used. So this could give us first guesses on the duration of an event. And when we talk about duration, we're talking about sometimes times beyond the typical duration of our warning. So if it's a long track supercell environment supportive of those, we may have PHI grids that are 2-3 hours out into the future, but with lower probabilities on the end. Tracy.
Okay, so here is the kind of picture of our timeline for this year 3. We did a report to the Weather Service. We established a test platform here at GSD. We're still working on that. And we had a code sprint in August with the entire development team, and Greg, as the product owner, was here. And I think it was extremely productive. We went through the software, but everyone was here so we could actually code on the fly and identify problems and issues. And out of that came a very comprehensive task list for the year, which we're now working through. So we need to develop the final set of functional tests. I think that's in progress. There's functional tests there, but we need to kind of polish those off. And then we'll continue to design, develop, and test through the year. Starting though in March and April, we'll then have the final HWT hazardous weather test bed. We're also doing biweekly collaboration calls with WPC, SPC, and we'll be doing a little bit of work for that arena of more of a national center perspective on probabilistic information. So we'll just be kind of scratching the surface of that, but we do want to start to expand the fee concepts into that area as well. Finally, we're looking at proposals for year 4 plus funding. So next slide, we have submitted a JTTI proposal, which is pending to complete development of the prototype functionality and have spring experiments continue in the hazardous weather test bed, plus some addition of new science. So we'll see, if that proposal, how that goes, but we'll continue to look for funding to make this work continue and actually come to operations. One thing we want to, leave you with is that for facets to become operational, it really will take policy and paradigm shifts as well. It's not just a technical problem, it's a whole new paradigm and way of thinking. And so policy will have to get involved in all of that. I think that's it for us, and unless you want to add any final thoughts, Greg, and then we could open it up for questions.
I think I'm good, ready for questions right now.
Okay.
All right. Thank you, Greg and Tracy, for a very excellent, comprehensive overview of the progress to date on this really important project. I really appreciate you giving us the full context of where it started, where it's gone, and how it's been operating under the auspices of the USWRP and the facets. I think particularly given our focus on R2O and how we're trying to improve that in NOAA, your particular project is kind of a really wonderful example of, I think, how we would like things to be. So congratulations for that. So at this point, we're going to open it up to questions from the online attendees and those in the room here in Silver Spring. John, do we have anybody with their hand raised at the moment? Yeah, so please use your the raise your hand feature if you'd like to ask a question directly. We can unmute you. Or use the chat. So, well, we'll give people a chance to think about their questions here and queue them up. But while we're waiting, I guess I'll go ahead and ask at least one. So, Greg, or I guess Greg, probably this one's addressed to the. Is it reasonable to say now that the prob severe guidance is kind of the de facto go-to for the actual fee in the putting the fee in the fee, I guess, or are there alternatives, viable alternatives that could be used, or either now or in the future?
Well, I probably wouldn't say exactly de facto go-to right at this point, because there are some issues with prob severe. First, it does a very good job of determining probabilities that storms will contain hail, wind, or tornado. Where it still has some challenges is in the identification of where the storm objects are in their motion. And if you're just using it flat, straight out of the box, it seems to do okay, but if you're relying on it to partially automate the process of creating feed plumes and which locations downstream are getting affected, some of these issues with the object ID and the tracking can cause bigger problems downstream. So you'll see on the list there in the end there, that's one of the new areas of science in the companion proposal that's going to be looked at. And one easy way to think of that is that right now the storm motion is based on the centroid of an object, And if two storms merge, all of a sudden the centroid will artificially shift kind of in the middle of these two storms now, and it's going to see that as a big change in the motion that's not actually a real, the real motion of both of those storms. So, so we see these problems with stuff like that. So, the lightning fee, the guidance that comes with that is actually very similar to what's done with Probsevere in terms of the storm identification and tracking, but it's looking at a whole bunch of different attributes to determine the probability of cloud-to-ground lightning. So, so there's that out there, and then there's going to be a bunch of other different kinds of guidance products out there. For example, I talked about the storm longevity guidance, which essentially is going to give a suggested duration of an event, that kind of thing. So,
okay, so just to make sure that I'm getting your salient points here, is that Probsevere is doing a good job with the actual probabilities in a snapshot, and as it is updated, but it has some issues with the storm motion vector that require the forecaster maybe to have to intervene and modify that more than we would like. Is that what you're saying?
Yeah, that's exactly what we're saying, and that's what PHI allows the forecaster to do in the semi-automated states. They can take over the motion of a Probsevere and put their manual motion on it, that kind of thing. So,
okay, got it. Thanks. So I think we have a question from Jonathan Blaze. Jonathan, are you there? Hang on, we're trying to unmute Jonathan. Jonathan, you're unmuted.
Yeah, I'm not sure my audio will work.
Yeah, we hear you, Jonathan.
Oh, very good. Yeah, just a quick question. I put it in the chat. This is obviously a huge change and a very promising and perhaps much needed kind of evolution of our products and services. I'm curious, with all the work going into it, can you estimate how many folks have their hands involved in this process? And, you know, researchers and other folks. I imagine this is a huge group of at least folks partially contributing to this process.
Jonathan, based on our recent workshop, we had our end of year 2 USWRP kind of get together. We had about 30 people in the room there, and that was not everybody. So I would probably put the numbers somewhere around 40 to 50 people who are involved in this.
That's impressive. One quick follow-up, if I could.
Sure.
So how, in terms of the actual forecast output, how does it evolve from being observational based in terms of radar data and then transition into any kind of model or forecast data that is included in it?
So on the hazard services fee side, that's something that we haven't done yet. We're doing everything based on extrapolation. On the prototype side of the experiment, they have been using rudimentary warn-on forecast information that provides downstream probabilities based on numerical guidance. So it's not necessarily just based on the extrapolation of a current storm now. So that's something that's under this bullet here, improved probabilistic guidance. Eventually, we'll be able to bring in some of these new guidance tools into hazard services fee to test out. One of the things that we're already talking about is how would the forecaster interact with objects that have a different forecast state that's different from just projecting where it is now. Whether or not we morph from a current state to several forecast states in the future, that kind of thing. So that's what the companion JETI proposal is going to be, one of the aspects that they're going to be looking at.
Very good. Thank you.
Thank you, Jonathan. We have a question in the room from a VIP from OER.
Not VIP. Greg, this is Chandra Kandaganta from OER. Hi, how are you?
Good to see you last week.
Me too. Yeah, it's a good presentation. So I have just one question. I was there when you had this, when you were testing this at hazardous weather test bed, but it wasn't clear to me. So when you were testing this with the forecasters, did the forecasters know ahead of time that what event they were testing?
Did they know ahead of time?
Ahead of time that the events.
Yeah, some of the forecasters did because we brought back some veterans, but in terms of the new folks, it varied based on how much exposure they already had to the facets concept. If they had already seen Lance Rotfuse or Al Gerard give the presentation somewhere, if they were perusing materials online, and then of course for our project, we provided some training materials ahead of time on the VLab that allowed the visiting forecasters to look through that before they came out. But for the new folks, the non-veterans, the first time they ever touched the software was the Monday that they arrived. So.
Okay, so they didn't know the event, which event they were forecasting, right? Before the new people, at least.
Yes. Yep.
Okay. Yeah, that's right. Okay. Thanks.
All right. Thank you, Chandra. So let's go to Phyllis Gunn. We're going to unmute you. You're unmuted, Phyllis. Go ahead.
Yeah. Hi, Steve.
Hey.
I have two questions actually. First, Greg, you alluded to your feed developer kind of moving on. So I was wondering, and you said you were going to address that later, so I was just curious if you're trying to find someone to follow in that person's footsteps. And then the other question I had regards NWS management and transition for facets. Is there a transition plan either, being considered or where's that in the process?
So I'll address the first question, and thanks for reminding me. I did forget to get back to that. The issue with the fee prototype now is that it may not have a developer working for it. So what we may end up doing is kind of capping what we've done with the prototype and transition all the functionality that's been put in the prototype the last 2 years into hazard services, and I'm in the process of inventorying that right now. What may start happening now in the future is that when we talk about running experiments with end users integrated, such as emergency managers, broadcasters, other folks like that, we may start to integrate them into using hazard services fee instead of the fee prototype. So we have to think about making the connections between the output software that the users are using and AWIPS now. That would be one thing that we would be thinking about after next spring. We wouldn't be doing it by 2018, but later than that. So in terms of replacing that person, I'm kind of not in that arena. I don't have much say in that, but I do know that the person who was there was very highly specialized as well as very highly motivated to do these things. So finding that right mix of somebody who has the technical qualifications plus the high motivation and the desire to innovate I think is going to be quite challenging, but you never know who we may end up finding. So second question regarding this was regarding transition plan. We have developed transition plans for the technology on this, but with regard to beyond that, it's still kind of in its infancy, and this is something that we kind of point out on that last bullet there. I think there's still going to be a lot that's going to be needed to be done in the policy arena with regard to implementing facets, because this is going to change operations in the forecast office, of course, and that's something that we're kind of looking at already through our experiments. But how the data, how the information and products are delivered and received in the downstream systems, both legacy systems and then any new systems that may come along that could be designed through partnerships with private industry and stuff like that. So one of the things that we are really making sure we don't do is the mantra "do no harm," and that is our legacy warnings. We are hoping will still look like they do now coming from this system. We don't want to break things downstream, but what will happen now is that there'll be additional information under the hood, more detail that could be made very useful to certain users.
Yeah, let me add to Greg and for Phyllis that the ultimately, as indicated, the paradigm shift and procedure shift and lots of other things that we would expect that this type of thing would have to be tested in the operations proving ground in a quasi real-time environment to work out the not just testing the software, of course, but how the new paradigm shift would work and what it needs to be proven out. We want to avoid what happened with the transition from the county-based tornado warnings, et cetera, to the polygon warnings, where we sort of did that, right in operations, which is kind of a dangerous thing to do. So there's a lot of things that are beyond the scope of what the project that Tracy and Greg are working on that need to be done on the Weather Service side.
Right, and I can jump in also to add to this one, which is that this JTTI proposal is again a 3-year proposal just to get us to an RL7. Some of the work that is needed to be done is as Greg mentioned, putting out those legacy warnings. We have not done that yet out of this system, and there's a lot of other things needed to polish it off and be ready then to be tested in the operations proving ground. So there's still a lot of work to be done to get to those readiness levels.
So is it
okay?
Sorry, I have one more question. So Steve, you mentioned the operations proving ground. So do things go there after they reach an RL7 level, or I mean,
depending on the potential impact on operations, we are making a concerted effort to bring them and prove them out there, and this would certainly fit that category as a huge potential. We know it's going to impact operations, so not everything needs to go there. If it's expected to be minimally impactful, etc. But this is certainly one that we would absolutely want to have there. And probably, with extended sessions with lots of forecasters, that sort of thing.
Yeah, this is a major shift for sure. Okay, thank you.
Yeah, you're welcome. Okay, let's go to Dave Riddell. You are unmuted, Dave. Go ahead.
This is Brian, Moretzky, Eastern Region. 2 questions. One, related to improving the probabilistic guidance. How is it envisioned to deal with the quote-unquote spin-up problem that exists within high-resolution models, that there exists some time of spin-up, and if you sort of tag the observational data with the model data, you would have some interesting, I would think, wacky type of spin-up. And you do that with some sort of extrapolation in between, etc. Obviously, the probabilistic guidance and high-resolution guidance, we could use some improvements there, but I'd be interested to know how that might be addressed. And then 2, I don't know if I missed it, but what are some of the differences between the feed prototype and hazard services feed? I'm not totally getting what the differences are.
Okay.
Go ahead.
The first question, I'll go ahead and just say, talk to folks like Jimmy Correa at the Storm Prediction Center, who's more closely connected to that research. He could give a much more informed answer to that question than I can, since I've not been involved in that part of it yet. With regard to the new guidance, once that new guidance has been vetted and tested and ready to kind of throw over the fence at us, on the AWIPS2 side, that's when we'll become more familiar with it. So the second question, can you repeat that again?
Can you describe what the differences are between the feed prototype and hazard services feed? Because you're talking about integrating the two, and I'm not sure I totally understand what the differences are.
So the feed prototype is more of a sandbox for trying out new things, but the big difference is that it was developed using technology that is not AWIPS2. So it's web browser based. The underlying source code is JavaScript. So it's using a lot of the JavaScript libraries to create objects and to do the what are called dynamic plume drawing and stuff like that. Because it's being developed as a kind of an experimental development platform, and by one person, that person was able to be very nimble in terms of adding and changing things on that platform during the tests. AWIPS2, of course, as you know, the platform is highly governed. It's using different source code. Java and Python. It does not have the capability to do some of the more dynamic graphical look and feel that the web browser-based system has and that kind of stuff. So the other thing that we have to consider with AWIPS2 now that we're bringing it operational is the issue of collaboration between forecast offices, both neighboring offices, but the entire CONUS as well, and even eventually OCONUS. But we have to deal with pretty much a national grid, that kind of thing. What do we do with, for example, long squall lines that may affect 2 or more WFOs at the same time? How we will deal with that? These are issues that the prototype doesn't deal with because the prototype is essentially single radar specific right now. So.
Okay. Yeah, that makes sense. Yeah, thank you.
I use this term. The prototype is the bleeding edge, and hazard services fee is the leading edge. But soon the leading edge will catch up to the bleeding edge.
Okay. Thanks.
All right. We've seen Ross Dickman may want to answer a question. Can you put that in chat, Ross? You don't look like you have a microphone. Otherwise, we don't know your question. All right. I guess we'll have to have Ross ask the question offline to Tracy or Greg when he has the opportunity. Okay, I think we will. I want to wrap it up at this point, and we're almost at the top of the hour. We are at the top of the hour, so I want to thank Tracy and Greg again for providing this really informative overview of where the hazard service fee project is at, the great progress that's been made. I think, as I said before, this is really outstanding example of the new NOAA R2O, at least in weather stuff. And great collaboration, a lot of thought put into this, and a lot of hard work. The collaboration does not come for free, as Tracy and Greg know. It takes concerted effort over the long haul, and you can't make assumptions. You just got to keep working at it, and certainly the fruits are here to bear today, we see. And I, hopeful that, the rewards of further funding to continue this, because there is a lot more work to do, will be forthcoming. So with that said, a reminder that we will upload the recording of this shortly after the end, and you can, we'll put out an announcement of that, and you can share it with your colleagues and friends and your mother, grandmother, whatever. And coming up in October, we have a topic is New Ice Accumulation Forecast Technique, the FRAM project, be presented by Brian Barhenbrook and Chris Sanders. And we will be looking to line up some more talks for the remainder of the fall and beginning of winter. If you have any suggestions, just shoot an email to John Chattel or myself. We would appreciate it. I think we have some candidates. I was recently at NWA meeting last week and saw some other really great talks. Hopefully we can entrain some of those people to give talks here in the coming months. So with that, we will end this session, and thanks everyone. We'll see you in October.